In this lesson, we are going to go over solving rational equations, part 1. So what we'll do is we'll apply our understanding of solving linear equations and quadratic equations to solving rational equations. Now, when you hear the word rational in math, you want to think of fractions. So something that's a rational equation would be like a polynomial on top and a polynomial on the bottom. Something in this form is what we're going to learn how to solve. So the problems are going to get longer, but they are going to become something like a linear or quadratic equation that we've all already learned how to solve. And then what we'll do is we'll solve proportions that simplify to linear and quadratic equations. So let's get started on solving equations. So without writing anything down, think about the value of the variable that would make the equation true. So for the first one on the left, we have w over 3 is equal to 5 over 3. Okay, so in order for these to be equal, you might see that w has to equal 5 because 5 over 3 equals 5 over 3. Okay, let me write that down. But notice something else that's curious here too is you could multiply both sides by 3 and the denominators would cancel out, and then you would be left with w equals 5 as well. So keep that principle in mind that when our denominators are all the same, that they could cancel out or we could let go of them. Okay, and then moving over to the second one, w plus 3 over 7 equals 7 over 3. What would w have to be? You're really looking at the numerator again because our denominators are the same. Okay, so we have w plus 3 equals 7 to get w is equal to 4 to make the equation true. Okay, so this is just a little bit of background on how we are going to go about solving rational equations. Okay, so example 1, solve for x. So 8x plus 1 divided by 2 minus 2x plus 9 divided by 6 over 10. So personally, when I'm dealing with equations that involve fractions, I like to make everything a fraction. So that means that this 10 is being divided by 1, or 10 over 1. The other thing I like to do is I like to take care of negatives out in front. This negative means negative 1 times 2x plus 9. So that negative is going to distribute to the entire numerator. Okay. Also, as I mentioned previously, that when we have the same denominators, that they can cancel out. And so that's going to be key for solving this type of problem. So we also need to determine our least common denominator. So our least common denominator, the way I like to think of it is what number can I get 2, 6, and 1, 2 using multiplication. Okay, and it could be one of the numbers already. So I can get 2 to 6 by multiplying by 3. I can get 1 to 6 by multiplying by 6. So our least common denominator is 6. So I'm going to rewrite the problem because we put 10 over 1, and then we also are dealing with the negative. So this problem becomes 8x plus 1 divided by 2, plus this is negative 2x minus 9 because the negative distributes, divided by 6 equals 10 over 1. So now what we do is we take each fraction on its own and figure out what we need to multiply the denominator by to get to the least common denominator, and then we have to do the same in the numerator. So for our first fraction, we would have to multiply the denominator by 3, which means we multiply the numerator by 3. Negative 2x minus 9 over 6 already has the 6. The last fraction, we need to multiply the denominator by 6, which means we multiply the numerator by 6. Okay, so what we have now is we have 3 times, and this goes to the whole thing, 8x plus 1 over 6 plus negative 2x minus 9 over 6 equal to 60 over 6. Okay, at this point, using what I talked about on the last slide, we can let go of our denominators or they cross off, and then we write what we have left. I'm going to write it over here. So we have 3 times 8x plus 1 minus 2x minus 9 equals 60. And look, we have a linear equation that we already know how to solve. Okay, so we start off by distributing the 3. So we have 24x plus 1 minus 2x minus 9 is equal to 60. I am going to combine like terms. So this will give me 22x minus 8. Oh, that should have been a 3. 24x plus 3, sorry. Okay, over here, 24x plus 3. So this is minus 6 is equal to 60. Solving for x, we add 6 to both sides to get 22x is equal to 66. Divide by 22, and we come up with x is equal to 3. Okay, so as I mentioned, the problems aren't necessarily getting harder. They're getting a little bit longer. There's some extra steps in dealing with the fractions, but it went to an equation that we already knew how to solve. Okay, so let's talk about, example 2, solve for x. So we have 4 over 3 plus 1 over 4 is equal to 1 over x. So we need to find our least common denominator. So when we have polynomials or variables in the denominator, something I like to think of when determining the least common denominator is what does one denominator have that maybe the other needs? Okay, so in terms of 4 and 3, I can get these both to 12, and I can multiply 12 by anything there. Okay, so 12 is part of our least common denominator. But this third fraction, or the fraction to the right of the equal sign, has an x in the bottom, and the other two don't have an x. So our x becomes part of our least common denominator. Okay, so our least common denominator is 12x. So what we do is we take each fraction on its own and figure out what we need to do to get each denominator to 12x. I'll also be showing you a different way to handle the least common denominator in this problem as well. So our first fraction, we would need to multiply 4x on the bottom, so we do 4x on top. For our second fraction, we would need 3x on the bottom to get to 12x, so we multiply by 3x on top. And on our third fraction, we need 12 on bottom, so we multiply 12 on top. So this gives us 4x times 4 is 16x. This is over 12x. 1 times 3x is 3x. And 1 times 12 is 12. Okay, so this becomes then 16x plus 3x equals 12. Like I said, I was going to show you another way to do this one. So what you'll see, or maybe what you've seen before, is you can take the least common denominator and multiply it to every fraction. So, or it's like multiplying both sides by the least common denominator, but I do it to every fraction so I can see my cancellation. Okay, and multiplying each fraction by the same thing is the same as what you do to one side, you must do to the other. So I'm going to multiply each by 12x. Okay, so now there's some division. We have 12x and 3. 3 divides into 12 4 times. So now we have 4x times 4. Plus 4 divides into 12 3 times. So now we have 1 times 3. X divides into 12x. Our x's cancel out to get 12. That should have been an x there. Okay, so now I have 16x plus 3x equals 12. This gets us to the exact same place. So whatever method you choose, whether you get all of your denominators the same, meaning you're multiplying each fraction by something different, and then letting go of the denominator, or whether you multiply each fraction by your least common denominator, you'll get to the same place. Okay, so now what we have to do is solve. So we have 19x is equal to 12, okay, and we'll divide both sides by 19 to get x is 12 over 19. Okay? And if you're nervous about getting fractions as answers, this is a little bit harder to plug in. The other thing you can do is do it again if you have time and make sure you get the same answer. Okay. We're going to go over solving proportions. So these are rational equations because we've got variables in the top and bottom, or polynomials in the top and bottom. But this happens when we have a fraction equal to a fraction. So you can use what we just talked about and get a common denominator. And since we went over that, and we'll keep going over that in our next lessons, I won't do it that way. I'm going to show you how to cross multiply here. Okay. So we have negative 4a over a plus 16 is equal to 8 over a minus 4. Again, when there's a negative, it's like negative 1 times the entire numerator. So this is negative 4a over a plus 16 is equal to 8 over a minus 14. Okay. So when we cross multiply, we cross, so numerator of one fraction times the denominator of the other. So this is negative 4a, and put things in parentheses. This negative 4a has to be multiplied to the a and the negative 14. You write your equal sign, and then you cross and go the other way. 8 times a plus 16. And now we have some distributing, and then we can solve this equation. Okay, so we distribute. So this is negative 4a squared. Negative 4a times 14 is 56a. This would be equal to 8a plus 8 times 16 is 128. Whenever you see your variable squared, so we have negative 4a squared, negative 4a squared, what kind of equation is this? You would use the principles that you know about solving quadratic equations. So this is not a linear equation where we're trying to get our variables to one side and our numbers to the other. We will either use factoring, square root property, or quadratic. So I am going to move everything that's on the left to the right because I like to keep my a squared positive. So I'm adding 4a squared to both sides, and then I'm subtracting 56a from both sides. So this gives us 4a squared minus 48a plus 128 is equal to 0. And then when we factor, our first step is to take out the greatest common factor. So I'm going to divide each of these by 4 to have a squared minus 12a plus 32 is equal to 0. So now we're looking at a squared minus 12a plus 32. Two numbers that multiply to 32 and add to negative 12 are negative 8 and negative 4. So we have 4a minus 8, a minus 4 is equal to 0. Now, when you're at this point, only the factors or what's being multiplied that involves a comes from a solution. 4 is just 4. You could technically divide it on both sides and it would cancel out. So we're really looking at a minus 8 is equal to 0 and a minus 4 is equal to 0. So a is 8 and 4. And now it's 4 because of this factor, not because of the number out in front. We'll do one more example with proportion. So negative 6 over x is equal to negative 15 over x plus 3. So this is what I mean by we have a fraction equal to a fraction. If there was like a plus 1 over here, it wouldn't work. Okay, it has to be one fraction equal to another fraction, just like it's set up here. Okay, so we start off cross multiplying. So we have negative 6 times x plus 3. We write our equal sign and then we cross and go the other way. Negative 15 times x. And now we distribute. So we have negative 6x minus 18 is equal to negative 15x. This is a linear equation, so our goal is to solve for x. We can add 6x to both sides. So we get negative 18 is equal to negative 9x. And then we divide both sides by negative 9 to get x equals 2. Okay, now something that I didn't mention on the previous slide, but I really should have, is when we're dealing with rational equations, we have to be very, very careful about our answers. In this class, you are not allowed to divide by 0. Okay, any number over 0 is undefined. Okay, and that's because if we were to say it's something, we would be saying 0 times question mark equals some number. You can't multiply 0 by anything and get a number out of it. So what all of that means is we have to check our answers. We have to, let me go to the next slide. So I'm going to rewrite the problem. Okay, this one would be 0 if x equals 0, and this would be 0 if x were negative 3. So as long as you don't get 0 or negative 3, you've got an answer. So we got x is equal to 2. So one thing you can do too is just check. Okay, if I plug 2 into this denominator, we're good. We didn't get 0. If I plug 2 into this denominator, we'd get 5, which is not 0, so we're good to go. So anytime we've got variables in the denominator, we need to be very, very careful that we're not going to divide by 0. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.